Dear Lord, look at this guy. The sculpted miracle of a man is Brian Johnson, the very moneyed former owner of Venmo, who literally looks younger every passing day.
I consider myself to be a professional rejuvenation athlete. The speed at which I'm aging is less than a 10-year-old. I spend millions of dollars a year. I do over 100 therapies in any given day.
What Brian really wants is to be 18 again. And of course, so do I. We just seem to be going about it in very different ways.
I try to get perfect sleep. I eat 70 pounds of vegetables. I work out an hour a day.
The science is still unclear as to which of us will hit the fountain of youth first. But the former Utahn thinks part of the answer lies within his newly claimed city.
I love this place. When I was looking for where to live next, I mapped out a few big cities in the US, and I wanted to find something where you could do and say and be anything you wanted.
And people a lot of times think about LA, Hollywood first. I think most people will be surprised that there's like all this other stuff going on here.
There's this huge invisible world.
Los Angeles first called to me when I was 18. I arrived here at the spectacular Pomona College, where I was a philosophy major.
I'm often asked, what does a philosophy major do? Well, I do the only thing I can do, which is show you people that can do.
LA's thing has always been that anything is possible here. Away from Hollywood fame, it's a city rich with car culture, aerospace dreams, and industrial factories. This is the LA that I love. And while you may not know it, LA is in the midst of turning into the most interesting manufacturing hub in the world. To begin our journey into this metallic underworld, let me show you Walden Speed Shop and its proprietor, Bobby Walden. He's part of LA's manufacturing legacy. He's been in the metal shaping industry for 35 years, building and fixing vintage car parts the old school way, by hand.
Metal shaping is an extremely old craft. But the thing holds true even from hundreds of years ago to now. There's only three things you can do to metal, and that's shrink it and stretch it and form it, which is kind of folding. Other than that, there's really no new technology. I really cut my teeth making Harley-Davidson body parts from scratch. And then the hot rods, started working on those and chopping tops and building panels and fixing rust. And then started building pieces of bodies, and eventually became building an entire body from scratch.
If you're gonna do what Bobby does, Southern California is the place to do it.
The cool thing about Southern California, first off, is the weather. Back in the 40s, after World War II, the guys came back. Now, these guys are kids still, and they have lived a life and seen things that we can't even imagine today. And they come back, they're alive, they're vibrant, and they want thrills, right? The first thing is they start with the cars. They were cruising everywhere, and then they were probably 10 drag strips around here. You could drag race every day of the week except for like Tuesday and Wednesday. It was 50 Mercuries and the crazy custom cars. Because of the aerospace industry that was out here, there was a lot of available material that you couldn't get anywhere else in the country. The cars kept progressing and getting better and better and better and better, you know. Los Angeles at one time, there were thousands of shops that did pattern making, small casting shops, and all these artisans, unbelievably gifted and talented men and women. But as time evolved and manufacturing started being sent overseas and automation came into play, then these skills and these jobs and these shops got swallowed up and lost.
Yeah.
If the trade or the skill isn't taught and perpetuated forward, then we go back, we regress.
Bobby offered to show me every twist, bang, and clang that goes into making a simple metal bowl.
If we're gonna make a bowl, obviously this thing has to curl up, so it has to be shrunk.
He is a patient teacher.
But it's real simple. That gives you a tuck.
So you're kind of just twisting back and forth?
Yep. Twist it like that. And then go back the other way.
Is this a disaster?
No such thing.
Get it in there.
All right. Perfect. Looks good. Serious. And now you go back in here and you flatten these pooches out.
Okay.
This isn't a glamorous thing that I do. It's hard work. It's cold in the winter and it's hot in the summer and it's loud all the time. And when you go home at the end of the day, you are tired.
If only we had a robot that could pick up some of that
Had a
slack.
robot to pick up the slack, you know, and something that you could like scan something and it could memorize it, keep the dimensions and all that stuff.
Maybe one day.
Maybe one day.
Yeah.
Meanwhile, across town, that very same day, I'm told that a group of robots is sometimes known as a colony. And this colony of robots belongs to Machina Labs and its co-founder and CEO, Ed Mayer. These are the sheet metal bending, ultra-modern successors to folks like Bobby Walden.
Sheet metal is the biggest metal processing sector out of all the metal processing. Pretty much most of the parts you see day to day are sheet metal parts. You're driving in a freeway, you're kind of in a sea of sheet metal, or you're sitting in an airplane. It's basically a sheet metal can. They don't really have a very agile solution to make these parts. They all basically have to build a factory for it before you can get your first batch of parts.
Yeah.
Factories that produce large metal parts, like car doors or airplane wings, can be the size of a football field and 3 stories high. Huge, very intricate, and not at all adaptable.
This is just a common problem in manufacturing, that a lot of factories are specifically built for the products they're trying to manufacture. At the moment you want to change your design, you want to change your material, you have to almost build another factory. So what we're trying to do at Machina really is, can we have that overarching automation that is not process specific? It's a platform that allows the robot to go pick up the right tool and apply it to the material so they can get the right part, the same way a craftsman or a blacksmith used to do these parts.
These bots have the skills to make fancy new shapes, and old ones that are too challenging for other companies to make today.
I know a lot of the stuff you work on is kind of top secret. Can we talk about all these things?
Some of it, yeah.
Yeah?
This one's an interesting one.
Yeah?
It's actually a composite mold for a drone wing.
Okay.
So they basically lay up composite on top of this, and then they put it in a vacuum bag and put it in a furnace, and then they get a composite part out of it.
Is this your donut operation?
Yeah, I know.
Giant donut.
This is actually like toroidal tanks is one of the most good designs for, like, you know, satellites tanks.
Okay, what kind, like a fuel tank or?
Fuel tanks.
Okay.
Yeah. One of the challenges with these is that it's very hard to manufacture. Back in the 60s, actually, NASA used to make these things, and they mostly relied on basically talented individuals.
People, we've like lost the knowledge of how to...
knowledge. And so we're kind of working with NASA to revive some of these as well.
But even if you're not NASA, just a regular Joe or Jane metal fanatic, you too can hire a pair of these robots to do your bidding.
This is your Machina starter pack if you're a customer. You get 2 robots, and you get this platform in the center that holds the metal sheets. That costs you about $2.5 million to get going. And then it's about learning this process of orchestrating the robots, using Machina's software, and getting going with these things.
To truly put these robots to the test, I had what's known in LA as the engineer's skin peel.
This is step 1 of having your face built by a robot is to get this mug scanned with a laser that's also mounted on a robot.
It's not super dangerous. It's a class 2 laser. It's like 1 level above a laser pointer. You probably want to close your eyes when we do this. Ready?
Ready.
All right.
Please tell it to be gentle.
All right. Eyes closed. 3, 2, 1. Here we go.
After the laser, lasered my face, the resulting 3D file was sent to these 2 fine workers. They set about making Metal Me, each with its own clearly defined role.
At each point in time is basically one robot is forming and the other robot we call like a support robot.
Okay.
So while one robot puts all its effort into deforming the sheet of metal, the other robot makes sure that deformation is only happening where they want it to. In this case, on the indent, increasingly looking like someone I know. It's just like me.
Good job, robot. Good job.
And the robot-generated wonders didn't end there.
So Ashlee, we made a little piece for you, kind of take as a souvenir from LA.
It's awesome. I feel like the Flavor Flav of robot machinery,
Yeah, it
robot
looks good on you.
blacksmithing. That is awesome, man. Thank you. I feel I've made it.
Admiring my glorious metal bounty, I couldn't help but wonder, what is it about LA that makes such innovation possible?
Every time I come to LA, it's this new take on manufacturing, and this way, a lot of it comes out of aerospace. But to me, it feels like if there is a manufacturing revolution taking place where all this stuff works and we make some kind of step change to a new age, it feels like LA is somehow ended up as the epicenter of that. Is this like coincidence, or this had to be here?
No, I agree with you. And honestly, like partially, it's because of SpaceX.
It's hard to talk about LA's manufacturing scene without acknowledging the Elon in the room. Like just about everyone here doing sci-fi building, Ed used to work at SpaceX, the aerospace giant located on the outskirts of Los Angeles.
I think one thing Elon did for the folks who went to SpaceX was like, he really broke that fear of testing with hardware. It was like, well, why don't we just make hardware the same way you make software?
Yeah.
Like, why don't you just test it and, every 2 months, 3 months, try something else? And a lot of folks who were exposed to that, I think got a little bit of confidence there. It was like, okay, yeah, no, I can put together a facility with the 22 robots and just figure this out.
Yeah.
Next stop, another former SpaceXer taking manufacturing to the stars.
When I was sitting at SpaceX working on the plan for how we're going to colonize Mars, my brain kept coming back to over and over again, how are we going to make things on Mars? We're not going to ship, billet, and machine it on Mars. We'll want to make it in situ while we're there. That also kind of planted the seed for me to kind of go into 3D printing.
Eric Palich, co-founder and CEO of Freeform, wants to make building-sized 3D printers with conveyor belts and assembly lines. And to do that, they gotta have a crap ton of lasers and the digital brains to coordinate them all. He's working on a prototype.
All right, so this is the machine.
This is it. Lovingly call it GoldenEye.
Yeah, because of the
although you
lasers?
can't- Yes, because the lasers.
The lasers are what make metal 3D printing possible, heating up a metallic powder and welding each new layer to the previous layer.
We have more lasers on a system that's running right now while we're talking than anyone in the world.
Okay, let's have a look. I just...
Let me get you a little,
Can I have a stool, please? My
Because-
viewing stool.
the viewing stool, yeah.
Yeah, this is crazy. You can just see all the lasers kind of going at once, right?
Yeah, all 18 should be going right now.
It looks like something engineered by a supervillain to kill a secret agent, all too slowly. But this machine represents a huge breakthrough for 3D printing. It's much faster, much cheaper, and much more precise than what has come before. It possibly gets 3D printing close to being mass manufacturing technology.
There has been this belief for many years that the only way to go faster is to trade quality. The real problem is that the machines today are, for lack of a better word, are dumb. You pre-program instructions and then you tell the machine to go do that. You just iterate on it until you get it right and then don't change it. What a shame for a technology that shouldn't care what the part is coming off the machine.
Right, I mean, the whole thing is about creativity and imagination and
Exactly.
sort of limitlessness.
Freeform undumbs these contraptions by collecting information on what the machine did and feeding that into a neural network that can then learn how to do it better next time. A process that requires an unholy amount of information.
It's actually kind of crazy. The amount of data we move here is like rivals like Netflix, you know, like the sheer magnitude of data.
All that data means Freeform can make insanely complex designs out of robust metal. And eventually, rocket engines, car parts, and whatever it is they make on Mars. At this point in my journey through Los Angeles, I was feeling that, like any other TV host in Hollywood, I needed a useless award for myself. So I had Eric print one up.
For exploring manufacturing in Los Angeles and doing such an amazing job, I present to you the Worldie.
Thank you so much. It's glorious. What's it made out of?
Metal.
That's incredible. Thank you. Thank you. Thank you.
Seeing what marvels can be accomplished without the touch of a human hand, I couldn't help but think of the Bobby Waldens of the world.
The nerd in me just likes the machines themselves and seeing what comes out of them. But like none of this stuff comes with many jobs. So there is this like kind of hollow feeling that accompanies this, even if it's a huge success.
We're trying to take the human out of the loop of the process itself because humans aren't good at that. But we're going to need lots of people to build these factories. We're going to need people to maintain these factories. Computers cannot substitute for human creativity. That's what we should be training people to do, to like deploy these precision robotics and maintain these precision robotics, you know, not like vacuum powder off a plate, you know?
Come on, buddy. Here we go. Let's go home.
Carrying around all this metal was becoming a real drag. So I skipped across town for something a bit lighter. Sugar. At a company that's invented a whole new way of making sweet treats.
Super proud of this. This is the current 3D printer. We designed and built it from scratch. You can see, like, it looks like a kind of commercial kitchen equipment, but it also contains all of the processes that we're familiar with 3D printing. It manages this dry powder, which is starch and sugar. And then we've got a print head over here, which moves across and actually prints the object. These 3D printers can go into any commercial kitchen in the US and even across the globe.
Very cool. And I could just eat it.
Yeah. I don't recommend eating that all in one sitting. But yeah, everything is edible, completely
Flying
edible.
off the walls.
For the taste test,
So we have a nice assortment of different things.
Chef Jonathan walked me through the menu.
We have dealer's choice here.
Okay.
I got some chocolate-covered sushis, or maybe something a little more refreshing, like our lime
Like a skull.
skull.
Just your classic skull?
Just our classic Shakespearean skull.
Oh, yeah, you could taste the lime.
Yeah.
It's sweet, but it's not as sweet as I kind of thought it was going to be.
It's like more meringue-like in texture.
That is what I was looking for.
Yeah.
It's like a meringue.
But Sugar Lab isn't limited to sugar. As long as the food can be dehydrated into powder, the team can print it. Think matcha, think kimchi, think sparkly stuff.
We do a lot of drink drops, dissolvables that we put in our cocktails,
Okay.
wine, champagne.
So you just plunk it? Oh, it's cool. You get the color and you get the fizz.
We could give it a little stir.
Can I taste?
Yeah.
Is it safe to drink this much glitter?
Yeah, it's totally food safe, edible glitter.
But there was more
We have a strawberry covered chocolate.
and more
Here we got our Everlasting Gobstopper,
and more.
a cranberry Frankenstein, one of our 90s bonbon shells, matcha Buddha for you, hazy IPA ganache bonbon, our glitter skull, it's our happy little pencil bonbon. We got our fun little octopus there. My favorite boat, drink drops,
It sparkles.
the green tea bonbon.
Oh, that's really good.
I don't recommend eating that all in one sitting. I don't recommend eating that.
The thing about LA, man, is that the ideas are so big. You can do anything here. You can print things out of sugar. You can buy Twitter with your spare change. You can mine asteroids. You can go to Mars.
Sugar Ashlee is right. In this city, the galaxy is truly your oyster. But how do you get there?
Welcome to LA traffic.
Well, that's next time.